Hi, I'm Skylar. So I looked at the Australian wildfires of 2020. So these last in Australia in general from September 2019 to March 2020. I looked at the Bega Valley region of New South Wales, which is very badly burned. 62.1% of the entire area was burned. Um, and so the goals for this project were to really visualize the vegetation health over time. I wanted to compare the Wadbilga National Park, which is a national park, to surrounding area to see how being a national park affected its vegetation, the recovery, and all of that. I also wanted to classify the Bega Valley area to determine burned areas both during and after the fires. And then my research question is really how does wildfire induced vegetation damage impact plant health and how different levels of impact affect vegetation recovery? Um, yeah. And so going into the project, I was sort of wondering like how much can you actually see from these satellite images? And the answer was a lot. You can see these burned areas in brown during the fires. And then after the fires, like a very late period after, you can see these being like back to normal, basically not burned. So that was nice to see going into it. So going from that, I went with a Sentinel-2 collection. I filtered this for clouds. I took 2 month medians of EVI, NDVI, NBR. The reason it was 2 months is 1 month had a lot of like bits missing, so I had to do 2 months to fill those in, so larger time period. I then created GIFs of the EVI, NDVI, NBR, and I took average indices over different ROIs and graph these for each month. So the different ROIs were like the national park, its surrounding area, and then the ROI as a whole. I also then created classified maps for early 2020 and late 2020 to late 2022. This was basically like the period during the fires and the period after the fires. And then I created an accurate assessment of these. So for the gifts, the blue is basically the lower value. So really when the burn is happening. Um, and so you can see just then it just happened. And one big thing I want to point out is right before the fires happen, a lot of the values in the entire ROI get really light, so that like lighter green color it happens right then. And that's a drought that's happening right before. And one important area I want to point out is this area right here that is pretty different. It goes a lot more light green to like blue during that drought period, which we'll see in the next thing, which is the average indices of ROIs. So I looked at that area and then Wadbilga, or which is a national park. Sorry. Um, and then I also looked at Bega Valley as a whole, and I used those as my ROIs to compare EVI and BR, and took like average values of those. And so the fires really happen in like September to January for Bega Valley as a whole. So it's like essentially right here the fires sort of start happening. And so for NDVI honestly doesn't do the greatest job at showing this, but I'll point it out now and then go talk about it more when we're looking at EVI and NBR. So there's a lot of vegetation health decrease for all three of these RYs, but a lot of it for like the most of it happens for neighboring Wabilga during the drought. Not a lot of decrease happens during the actual fires for this neighboring area. And this is only iterated upon in the EVI NBR. For Wabilga National Park itself, like the fires very clearly hit very hard. You have a steep decrease. Same for Vega Valley as a whole. Steep decrease in vegetation health during the fires, all the way down to where that neighboring area is. And then after the fires, an important thing to notice is Wadbilga doesn't get back up as high as Vega Valley, indicating that was hit harder by the fires and having a hard time recovering. Going to EVI, it's essentially the same stuff. The neighboring area really gets hit harder before the fires. Like September to January, right here, there's not really any decrease in EVI. So it indicates that not much of the fires actually happened in that neighboring area. Like in at the same time period from like September to January, most of that decrease is happening for like Vega Valley and Wadbilga. Like there's not much decrease before that, but during it, it really goes down. Which is important to tell you that the drought really is what mostly affected in that neighboring area. And then again, Wadbilga, the national park, is hit harder than Vega Valley as a whole, and then all of them really steadily decrease again to pre-fire levels. So it's like back to what it was before. And then NBR, which is I really feel is the best, which makes sense. It's for analyzing burned areas, and this is a burned area. Um, that neighboring area once again hit by the drought really hard and then isn't really hit too much by the fires. Like there's a slight decrease, but it's not a ton. And especially compared to Vega Valley and Wadbilliga, um, Wadbilliga again starts higher, and then once it's hit by fires, it really drops in NBR. Same with Vega, and then Wadbilliga is lower than Vega Valley as a whole. But then they all slowly, steadily decrease. So it was interesting to see like the effects of a drought on different areas, and especially how heavily like a national park with high vegetation is hit harder than the ROA as a whole. Then finally, for my other route, the classifier and the accuracy estimate, I trained a CART classifier on the two time periods, one during the fires, one after the fires. This is because it's basically better at the classifier is just better if it's trained and it's not biased towards like if you only train it on uh, training points during the fires, it's going to be good at images that are from during the fires. It's going to be worse at if you're going to apply it to an image that's like way after the fires. So I also did validation testing points from these time periods, which resulted in 89% total accuracy, 94% total accuracy for the during fire image, and 84% accuracy for the post fire image. And then based on the classifier, the amount of burn forest went from around 60% to about 23%. The amount of healthy forests went from about 39% to around 74%. This is for the entire Big Valley area. And so you can see a lot of the burned area, burned forests, essentially heals into healthy forest or like sort of healthy shrubbery. I call it forest, but it's really any sort of healthy vegetation. So yeah, those are those images. In summary, some difficulties were all the calculations and graphs were done in single script, which took a while to run. In hindsight, I should use a data set with a lower spatial resolution or split this into multiple scripts. Source of error, I should use more training data and validation for the car classifier. I was already using like 200 to 300 points, but I could have used more, especially for the validation data. I also should have masked for water for NDVI, EVI, and NBR calculations, especially for the whole ROI, because there's a little bit of water in it. So I should have accounted for that. And also for the GIFs, even though I expand that to a 2 month period, if you go back and watch the GIFs, there's a little bit of choppiness that could probably helped by increasing that time period more. But then also you lose a little bit of like fineness of them. But then, yeah, so for future work, instead of using the classifier on just the median periods during the fires and the median period after the fires, do the same method of creating an image for every 2 months and see how that tracks over time. So creating a GIF or those same like index graphs over time, but instead tracking the amount of like burn forests and healthy forests and change over time. And so like a line graph similar to NDVI, EVI, NBR, but instead for the amounts. And then also add dates to the GIFs. Thanks.